Welcome to our channel. Leave a like and subscribe to stay updated on our upcoming videos. How far must a planet be from a star to support life? Not just any life, but the kind we know, one that relies on a delicate balance of chemical, physical, and atmospheric conditions. And what if this star were a red dwarf, one of the most common types in our universe? How would the rules of the game change? Imagine a small star called Wolf 359, shining faintly in the Leo constellation, less than 8 light-years from Earth. It is so close yet so seemingly insignificant that it could easily escape notice, but in reality, it holds extraordinary mysteries. Wolf 359 is not just any red dwarf, it is a window into a cosmic chapter that may reveal the secrets of life beyond our planet. Scientists from the Harvard-Smithsonian Center for Astrophysics have decided to study this star with the meticulous attention of an investigator analyzing a crime scene. Their goal? To understand the conditions a planet must meet to develop and survive in such a hostile environment. Their findings were presented at a major scientific event, the 245th meeting of the American Astronomical Society in Maryland. This conference opened a new chapter in our understanding of red dwarfs and their habitability, generating significant interest in the scientific community. Wolf 359, with its dim light and strategic location in the cosmos, serves as a perfect laboratory for exploring the possibilities of life in extreme environments. But what makes this star so special? First, it belongs to the most common class of stars in the universe. Red dwarfs make up about 80% of the stars in our galaxy. This means that by studying Wolf 359, scientists can gather data useful for understanding an incredibly vast number of similar star systems scattered throughout the cosmos. Additionally, Wolf 359 is relatively close, less than 8 light-years away, making it one of the most easily observable stellar objects with modern telescopes. Its proximity offers astronomers a unique opportunity to analyze its physical characteristics, behavior, and peculiarities in detail, such as its magnetic activity and radiation emissions, which are crucial for assessing the habitability of potential orbiting planets. Red dwarfs like Wolf 359 are far less luminous than our Sun. Their dim light means that the habitable zone, the region where a planet could theoretically have liquid water on its surface, a fundamental condition for life as we know it, is much narrower. For Wolf 359, this habitable zone is much closer to the star compared to our Sun and is roughly 15% of the Earth-Sun distance. This means that a planet orbiting this star must be at an extremely precise distance to maintain conditions suitable for life, close enough to stay warm but not so close as to be exposed to lethal radiation or so far away that it becomes too cold for liquid water to exist. However, light alone does not determine habitability. Another crucial factor is stellar radiation. Red dwarfs emit significantly higher levels of radiation compared to Sun-like stars, especially in their younger, more active, and unstable phases. Using data from X-ray observatories such as NASA's Chandra Space Telescope and ESA's XMM Newton, scientists analyzed the intensity of radiation emitted by the star. The results were surprising, and somewhat concerning. Wolf 359 emits a very high amount of harmful radiation, raising crucial questions about whether a planet in its habitable zone could truly support life. A planet within Wolf 359's habitable zone would need special characteristics to withstand such extreme conditions. For instance, it would require a dense atmosphere rich in greenhouse gases, such as carbon dioxide, which could act as a protective shield against harmful radiation. Without adequate atmospheric protection, life as we know it would be impossible. Moreover, the planet would need to be at just the right distance, not too close, to avoid being constantly bombarded by lethal radiation, and not too far, to avoid becoming an icy, inhospitable world incapable of sustaining liquid water. Another fascinating aspect concerns the frequency and intensity of stellar flares from Wolf 359. In just 3.5 days of observation, astronomers recorded 18 X-ray outbursts from the star. Imagine a constant rain of charged particles bombarding a planet's surface day after day, week after week, year after year. Even if the planet had a protective atmosphere, the question remains, could it retain this atmosphere long enough for life to form and survive? Scientists estimate that an Earth-like planet at the center of Wolf 359's habitable zone could maintain an atmosphere for nearly 2 billion years. However, the star's constant magnetic activity and flares could significantly shorten this duration. There are 2 candidate planets orbiting Wolf 359 that could potentially support life, but they have yet to be confirmed. Neither of these planets is located in the habitable zone of Wolf 359. One is too close to the star, exposed to lethal radiation, while the other is too far and too cold. Despite this, scientists remain optimistic. As Scott Walk, one of the study's authors, explains, the probability that Wolf 359 hosts additional planets, perhaps more suitable for life-friendly conditions, is high. Beyond the right distance and atmospheric protection, another fundamental factor is stability. Red dwarfs are notoriously unstable, especially in their early stages, when they emit massive amounts of radiation and flares. However, once the star calms down, it could provide stable conditions for billions of years, offering a long time window for life to evolve. This aspect is crucial because a stable star is a prerequisite for life's evolution. One of the most intriguing questions for scientists is how stellar flares affect the chemical composition of a planet's atmosphere. Intense radiation could destroy complex molecules, such as organic compounds, making it difficult for essential life-forming compounds to emerge. However, there is also a fascinating possibility: the same radiation might, in some cases, trigger chemical reactions that help create organic molecules. This could, in theory, lead to life forming in a completely different way from what we know. Observation technologies are rapidly advancing, and instruments like the James Webb Space Telescope promise to revolutionize our approach to studying red dwarfs and their planets. With these advanced tools, we will soon be able to directly analyze the atmospheres of distant planets, searching for signs of life or conditions that might support it. Imagine the excitement of discovering a chemical signature indicating the presence of oxygen, methane, or other gases, just like on Earth, that are associated with life. The question of habitability around Wolf 359 is not just a theoretical exercise, it is a crucial step in understanding the possibilities of life in the universe and answering one of humanity's oldest questions: are we alone in the universe? Thanks to today's instruments and technologies, we are peering deeper than ever into the secrets of the cosmos, and Wolf 359 is just the beginning of an extraordinary journey.